Okie smoky dokie. What numbers did we do?
8 for 34. Evens.
If you say so. Just as I do, in fact, say so, because you said so, so
Well, I
there,
said
so.
You said so.
Yeah, I know, that's what I said.
Hated me.
Yeah, that's what
Yeah,
your mom said. It
It
gave up on you.
Like, it was still recording, but it just paused on the frame for like the last 10 minutes of the thing.
She was just listening to it?
No, it didn't even have audio, it was just. So I couldn't see the homework because it cut off before like I even left class.
Sad.
Oh.
But her mother rescued her, so it worked out okay.
Commented on the video and you're not responsive. Like, okay, times.
Pull out the big guns.
Can we communicate through Classroom?
Can you? Yes, that is possible, I think. I don't know. I think you can message me through there.
Like,
You can also send email, but yeah, the likelihood of me seeing something on Classroom is less. All right, number 8 is -5 plus -3 over x plus 8 over x plus 7. Fun fact, in Algebra 2, I was able to tell the Algebra 2 students that in Precalculus, we were learning how to take the answer that they got and put it back to the beginning.
They're probably like, what's the point then?
Like, wait a minute. They were like, oh no. Okay, number 10 is x squared minus 2 plus 3 over x plus 1 over x minus 2. Number 12 is x minus 3 plus negative 1.5 over x plus negative 14 over x minus 2 plus 13.5 over x plus minus 4. 14 is 6 over x plus negative 1 over x minus 2 plus 4 over x minus 2 squared. 16 is 1 over x plus negative 6 over x plus 4 plus 10 over x plus 4 squared. 18 is -3 over x plus 3 over x plus 6 plus 8 over x plus 6 squared. What did we go through? 34. Number 20 is on a different page, so hold on. Were they sad? You what?
I have like 0 questions. I actually understood all of it.
All right, number 20 is x over x squared plus 4 plus x minus 5 over x squared plus 4 quantity squared.
Oh, maybe I didn't have as many questions as I thought. I got the x's and then square, and I was like, is that correct? I don't know. And I stopped and did English homework.
I see. 22 is 8 over x minus 4x over x squared minus 2 plus 25x minus 25 over x squared minus 2 quantity squared. 24 is -5x over x squared plus 2x plus 3 plus 9x plus 4 over the quantity x squared plus 2x plus 3 squared, quantity squared. Number 26 is 8x over x squared plus 1, excuse me, plus 1 over x plus 2, and 28 is invisible, there it is, -2 over 3x plus 2 plus 1 over x minus 1. 30 is 3 over 4x plus 0.25 over x minus 1 plus 1 over x minus 2 squared. 32 is 1 over x minus 1 plus 0.5 over x minus 1 quantity squared plus 1 over x plus 1 minus 0.5 over x plus 1 quantity squared. 34 is -2 over 3x plus 2 and 1 over x minus 1. Where are our questions today? 12 is as good a place to start as any. we're going to have to divide first. X to the 4th minus 9x cubed plus 24x squared minus 4x minus 12 all over x cubed minus 6x squared plus 8x. Nice.
How do we know we're supposed to divide this? The top is 1 greater than the bottom?
Yep. Well, any amount greater, but yes.
Oh, okay. So that's the big.
Yeah. The degree, if the degree of the numerator is greater than the degree of the denominator, then yes, you have to divide first. I would argue that waiting to factor that x out until after you do the division is going to be the easier mental gymnastics to go through to do this problem. So let's divide first. Minus 6x squared plus 8x goes into all of the rest of that mess. X to the 4th minus 9x cubed plus 24x squared minus 4x is 12. So x cubed goes into the x 4th x times. And then we distribute. X times x cubed is x to the 4th. X times negative 6x squared is negative 6x cubed. X times 8x is 8x squared. Then we subtract, right? So minus, yes. This one cancels. Negative 9x cubed plus 6x cubed is negative 3x cubed. And 24x squared minus 8x squared is positive 16x squared. Bring down minus 4x. Does x cubed go into negative 3x cubed? Yes, in fact, it does.
Negative 3 times.
It does go negative 3 times. That was the worst I've ever done. Okay. Negative 3 times x cubed is negative 3x cubed. Negative 3 times negative 6x squared is positive 18x squared. Negative 3 times 8x is negative 24 x. And then we subtract. Plus, minus, plus. This cancels. Yay, we did something right.
Negative 2x squared.
Yes, it is plus 20x. Bring down the minus 12. Does x cubed go into that? No, it does not. So we are done with that phase of the plan. So now we have x minus 3 plus negative 2x squared plus 20x minus 12 over x cubed minus 6x squared plus 8x. Now what?
Now we take out an x from the bottom
Yeah.
and turn it into factors.
Can you factor the top too? Or do you want to?
Maybe.
If you
Probably not, because we're going to have to like FOIL stuff back out again later anyway. So
don't touch the numerator.
probably, yeah. I mean, you could, but you may have to undo your work later. But it would turn back into that, so it wouldn't be that hard work, but you know. So x and x, 8 and 2, oh, yeah. Just kidding. That doesn't even make any sense. 4 and 2 minus minus.
Minus.
so then we turn it into the ABC thing?
Yes, then we do. So we're going to have equals a over x plus b over x minus 4 plus c over x minus 2. And then we hit it with napalm. X and then x minus 4 and x minus 2. And then all of that mess gets multiplied times all of that mess, which probably on the left side we want to just use the unfactored version, right? And ultimately do negative 2x squared plus 20x minus 12 times x cubed minus 6x squared plus 8x, right? And on the right
Because
side,
that cancels out, right?
I missed something. I'm sorry.
what'd you miss?
Whatever, these two.
This is what is going to be on the left side of the equation,
Yeah.
the numerator. And then on the, so this is just all, it's this unfactored, because when we do all this stuff, we're going to have to distribute it anyway. So it's going to be easy, instead of distributing twice and turning this back into this, since we know what it is.
Doesn't it cancel out? Is that
Oh
true?
yeah, it does. I don't know what I'm talking about. Yeah, it does cancel out.
Is this the entire point of us doing
Yeah, that over that, it's to torture you. That's right.
So x minus 3.
That's what's on the left side. Great.
So what happened to x minus 3? Oh, wait, that comes in later. Just kidding.
Yeah, we'll show that back at the end, or get counted 1 point off because we forgot. One of the two will happen.
Yeah, probably that one.
Okay, so then we've got a times, I'm tempted, but I won't. Okay, x, oh actually I don't have to be tempted. It's just that, yeah? X squared minus 6x plus 8 plus b, well yeah, but then you're gonna have to turn it into this because you're gonna have to distribute the 8. So, times x minus 2. Look, Alexa, I didn't forget the x. Are you proud? Now, I still could forget the c. That's the other one I kept forgetting the other day. But, you know, x times x minus 4. Great.
That's what I did wrong. I would have done everything except for a. Why is a multiplied by x squared minus x is 6x plus 8?
That's this. That's what it doesn't have.
It's not in that though. Wait.
If I distribute this back out, this is what I get. And I know that
Oh,
because
distribute it
I know that because I got that from this. So I didn't even have to think. I just had to copy down what I already had.
So do you have to distribute it back out?
Yeah, because yes, because you're going to have to distribute the a into it.
Okay, cool. Yes.
Then we start distributing a whole heap of nonsense. Hayden, did you forget about homework this day? Mm-mm. Oh, so you forgot about the homework that you slaved over. I see. Oh no. So I see. So ax squared minus 6ax plus 8a plus bx squared minus 2bx plus cx squared minus 4c. All right, we've got x squared terms, right? Here and here and here. That equals a...
Wouldn't it be 4cx on the end?
Yes? Oh no, I did forget it. But I didn't forget all of them. Okay, a plus b plus c times x squared. Now we've got x terms, this one, and this one, and this one. So plus, I guess, negative 6a minus 2b minus 4c times x. Then we've got no x terms, which is that lonely guy. Great, now what?
Oh, just that.
They
Ah,
equal
that's
the
so, I'm
bits.
so dumb. I'm so dumb.
Okay, what did you do?
Why is there 2 pluses there? Sorry.
Because magical unicorns. Okay, what do we do now?
They mean nothing. He's just selling.
Oh, he just.
I just-
Okay. We match them to their bits from the.
We do match them to their bits to make a system. So, bits is still a weird word, but yes, it does fit though. Look, I went from 2 pluses to a tiny plus. So exciting. -2, negative 6a minus 2b minus 4c equals 20. And finally, 8a equals negative 12.
Oh, that's a 1 unit thing.
Yay, we like those.
Negative 12, you said?
Yeah, why did I say that? Don't just copy. Why did I say it?
I'm looking.
Okay, he's figuring it out. He's good about figuring out after copying.
Oh, yeah.
Is it 28? It's from the division problem, it's 28x.
28x. Where are you saying, where is 28x?
From the answer of the division problem.
It's a 20, but it just looks like
Negative 4 plus 24 is 20.
It looks like an 8, I'm sorry.
You gotta scoot closer, bro.
No.
Not about it.
That's the right division.
So I am going to engage with that. You're just being funny, but I'm going to engage on that because as I am on the internet right now. Because I'm going to say something that is controversial and yet true. The burden of being educated is on the student, not on the teacher. True facts. Because if the student does not engage with said material, this is not what you're saying. You're just like, I'm not chastising you. This is just words. Because the student must engage with the material and the teacher. So you cannot go and say, oh my gosh, it's all the teacher's fault. Hog wallops. False. Not true in the slightest. Divide that by 4 and we end up with negative 3 halves.
I never figured out why the 12 is there.
Which 12? Okay. Well, thank you. I'm glad you said that before we moved on. This is on the left side. So this matches with this one.
I'm sorry, real quick.
He's just tiny and written in a weird place because for some reason my brain got confused and was going to multiply a bunch of other crap there. So
I knew that. My brain's just not there today.
your brain just got confused now.
Okay.
Okay,
So this is where I got stuck.
great.
Is that 3?
Yes.
We should substitute that into the other two. Let's do it. So now we've got negative 3 halves plus b plus c equals negative 2. And negative 6, I'll write it all the way out, why not, times negative 3 halves minus 2b minus 4c equals 20. Because see, now we have a 2 by 2 system.
Elimination.
Yeah, we should clean it up first, but sure, elimination or Kramer's rule or any other thing, who cares? Great, so on the top one, what would we do?
You would move the negative 3 halves to the right. So that
By
would be
adding, yes.
b plus equals negative 1 half.
Oh, you're just moving it over. Okay.
And here, this would turn into positive 9. And we would subtract that from both sides. Isn't it fun how in precalculus, by the time we get to precalculus, Algebra 1 me would never write work like this. But then in pre-cal, we'd sometimes go a little bit YOLO. Because we're not trying to learn that concept, we're trying to learn this one. Okay, so we've got B plus C equals negative a half, no, negative, yeah, it is negative 1/2. I was right. Negative 1/2.
Negative 2b minus 4c
Yes.
equals 11.
Then we can multiply the top one by 2.
We could multiply the top one by a positive 2.
Oh, I see why we did that now. Okay, cool.
We got a 2b plus 2c equals negative 1. Look, we even killed the fraction. Look at us. Then when we eliminate, that cancels. Now we've got negative 2c and positive 9, and we put fractions back in, but that's fine. Yeah, it's 10. That's what I was tricking you. Divided by negative 2. C equals negative 5. And then we shove all of those things back into probably this one. So negative 1 1/2 minus 5 plus C, negative 3/2. I just wrote it that way because it's going to be easier for me to combine these without thinking about it too hard. See, it's at this point you realize, wait a minute, I used to be so excited that I could use a calculator, and now I barely use it. Then we add 6 1/2 to both sides. We end up with C equals positive 4 1/2.
Do you want it as a mixed number, or do you want it as a...
Well, we may end up having to like yank it around and stuff. What is, I think the key actually leaves it as a decimal or something, doesn't it? Don't I remember reading 4.5 on something? What number is this?
Wait, why are we solving C twice?
Why did we what?
Why are we solving for C twice?
We don't. We solved for.
What?
That one's supposed to be B. The negative 5 is B.
Oh yeah, just kidding. This is,
Wait.
No, the negative 5 is
things, Sean.
this is over here, and it's still B.
Okay, so that's B.
And also it'd be a positive 5, wouldn't it?
Well, that one's a negative 5 because 10 divided
No,
by
I
negative
was,
2 is negative 5.
Oh, silly today.
And then we have to shove it back in its answer form by writing those on top of all the things. So we've got, look, we didn't forget, x minus 3 plus negative 3/2, I don't know, whatever, over x. Actually, honestly, probably truly the best way to write that answer, which is not what they did in the book, would be negative 3 over 2x. Arguably, that would be a better answer than what they put. But, and then,
Would you count off if we left the fractions on?
oh yeah, I love counting off for silly stuff like that. No, I wouldn't. Actually, it's pre-cal, so sometimes I do love counting off for silly stuff like that. But no, not this particular context. And then we write all the rest of the answer. Great, great. What other questions, children? 24.
These problems are ridiculous.
Ridiculous.
It took up really all of my page space.
So what you're saying is I need to start in that corner.
My page space.
Well, I know, but if it took up that much on yours, it might take up that much on mine, unless there's something that you were doing that you didn't have to do.
I use half the page.
Oh, no. Oh, no. Isn't pre-calculus fun? Pre-calculus is so much fun.
We love precalculus.
I don't usually write that big, but when I'm trying to figure things out, I do.
Garrett, look at you now. Did you ever imagine that when you were in pre-algebra that you would be doing this? This is,
No, not really.
you're like so far advanced.
I don't know if that's true, but.
Oh yeah, conics next. We get to go back to graphing. So much fun.
Do we get to use calculator?
It won't really help you.
We'll put a graph.
Is that next unit or is that next?
Actually, yeah, you can, but I'm not going to teach you how to do it, so, whatever. Yeah, the next unit, we're going back to conics, graphing circles and parabolas and hyperbolas. Okay, 24. If that isn't the epitome of hyperbole. Why are you turning into a snake?
Because my brain is not braining.
Oh no.
Because we did it with 5, I didn't know when to do the A and the, like, I don't know what I'm saying.
What the heck?
I'm just copying down the problem. Where are we? What the hecking right now?
Nothing to do with anything around me. It was just my brain.
I see.
It was me being stupid. Like, I read negative 10x squared and totally did not write that.
So the one on the bottom is bigger than the one on the top.
True. It is. So no division required. That's accurate.
Can you factor the bottom?
I don't think so.
It doesn't factor. Actually, we had that exact polynomial on an Algebra 2 problem earlier at the end of the problem, but it was in the numerator. And we were like, no, it doesn't
Okay,
factor.
So we stick it in the.
Patterned.
Would it have to be ax squared plus bx plus c for that, or am I being silly?
Oh, this whole thing. Oh, gracious.
No, it'd just be ax plus b. No, I'm being silly.
Okay. Now that we're done being silly, what should we write?
Ax plus b over x squared plus 2x plus 3, and then plus cx plus d over x squared plus 2x plus 3 squared.
How do you know where to put the A's and the B's? Is it just based on how many numbers are in the numerator?
We start with A, and then we do the alphabet, which I'm struggling to talk and write at the same time. And I'm kind of just being
Based on how many
snarky, but
chunks you have in the denominator.
Yeah, but sometimes A is by itself. and
Well, that's when
sometimes
we
it's
have
not.
the x taken out by itself.
yeah. So if we would have factored out an X or something, then you would have had the A over the X.
So, okay, the amount of, so x in the denominator, if you have just an x in the denominator, you have an a with no x in the numerator. If you have an x squared in the denominator, you have an ax in the numerator. So it's one, what would that be called?
I was barely paying attention. I don't know.
When you have an x and then you have an x squared, what's the, there's just two. Okay, whatever. So you have one x-ness less
Yeah.
One x in this less.
So-
in the numerator than in the
So
denominator.
the denominator is how you know how many fractions you have.
Yeah.
And
Yeah.
you kind of just put the top ones
Mhm.
based on. So
Yes.
if there was like 7, it would be A over X plus,
Not over, but
yeah. So
Yeah.
if there was 7, then you'd have 1, and then you'd have 3, and then 3. Okay.
yeah, you
So why
follow
don't-
the
Why don't
pattern.
we have 3 here? Why don't we have F and E? Because there's 3 things.
There's only.
ABC.
Because squared.
Because it's based on how many chunks you have in the denominator. So
What
you
does
have,
chunks mean?
okay, so the way I'm thinking of it is the x squared plus 2x plus 3, that's one chunk, and then x squared plus 2x plus 3 squared, that's a different chunk. And then if we had like an x by itself, that's a third chunk.
Got it. So we have 2 chunks because it's squared.
Mhm.
Okay.
Yes.
My brain beans are making sense.
Okay. Here we go. Are we ready?
Yeah.
So we just have to
the left is going to stay the same, right? Great.
I mean, right. No, yes, left. Okay, left of everything. Okay, never mind.
What we're doing here is multiplying.
We are, yes, I was going to write that, but I was going to only write it over on this right side because to save space.
You're gonna have to set something to 0.
Go.
And then so,
Ooh, this is the weird part.
So this one doesn't have one of them, so it needs one of them, right? Right. So ax plus the b times x squared plus 2x plus 3, then plus cx plus d. We don't have a rogue x this time, like the example we did the other day. So that's nice. Less to forget to write down. Yes, sir.
Just kidding. Got it.
Okay. Okay, big old fat distributive property. Here we come.
I was so wrong, so confidently.
Well, I have been telling you for years to be confidently wrong, so that's good. You've listened to something. Cubed, and then ax times 2x is 2
I'm going to have to put the equal sign all the way
ax squared, and then ax times 3 is plus 3ax. B times x squared is bx squared. That's easy. The rest are easy. I think we can get away with not looping on this chunk. Bx. That's when I'll make a mistake though. You watch. Plus cx plus d.
Rearrange them.
Got the QB one all by his lonesome. Ax cubed. We've got a squared one. So plus 2a plus b times x squared.
What?
It's the same as we did last problem. The x squared terms, this one and this one. Factor out an x squared.
Oh, okay.
I'm gonna go do myself some more.
Do it.
Okay, okay.
X terms here and there and everywhere. So plus 3a plus 2b plus c times x. And then the no x term. So plus 3b plus d. Great. Now what? Systemify it.
System of I.
A equals -5. And then 2a plus b equals -10. And then 3a plus 2b plus c equals -6. And then 3b plus d equals 4.
Oh,
We can definitely solve for b.
we can substitute easy, yeah.
Yep. Substitute right here. So then we've got -10 plus b equals -10.
Wait.
So yes,
You'll
b
solve for b
does
now.
equal 0. We substituted 5 in here. 2 times -5 is
Yeah,
-10.
okay.
We do, which is grand. And then we substitute b into this one.
then it's 4.
And we end up with d equals 4. Great. And then we can substitute a and b into here. End up with -15 plus 0 plus c equals -6. We add 15 to both sides and we end up with c equals 9. And then we start shoving stuff into things over here. So what is a? -5. So -5x, b was 0, great. So over x squared plus 2x plus 3 plus, the c is 9x, the d is plus 4 over x squared plus 2x plus 3 quantity squared.
Sorry, I'm still behind.
You should take a picture of that and send it to Britain.
Very happy to
She
understand
gets
how to
mad
do
when
this.
I try to talk to her about pre-cal.
Yeah, well, you can tell her to get off, to quit whining and just actually take pre-cal.
She gets mad and tries to tell me how hard
Figures
algebra 2
equals.
is. I'm like, I know, I took it.
Okay, sorry. I just finished the.
I know, I was paused.
So this the answer.
That's sticking it back in the thing from the top.
That's sticking it back in here, yes.
Oh yes. Okay. Take this easy. And you put in.
A right
plus
here.
0. Okay, that makes sense.
Good.
Okay, cool.
Okay, cool. Any other questions?
26.
26.
We don't have to go over any more lessons in class today, right?
That is correct. We do not. You have a test on Tuesday after spring break.
So it's just studying ball.
Yep. And you got plenty to study, so that's good.
Between the 4 lessons.
I know. There's only 4 lessons, and there's so much. So much in there. That's how we roll. Algebra 2 and beyond. I say that actually, Cal 1 is pretty easy, honestly. Cal 2 is hard, but Cal 1 is pretty easy.
I want to take Cal 1 now.
That's how they get you.
That's how they get you. 26. Oh, is a picture, but we have an equation, so great. What is your question about it? Like you know what to do, right? You just made a mistake, or no?
The squared in the thing at the bottom.
Yeah, that's fine. Okay, I just wanted to make sure it wasn't just because of the picture or some silliness like that. Okay, great. So 26. It's the same type of problems, but with context, right? Right. Okay. So we're given this expression, basically. They write it as a function, but we don't really care about that part because all we're supposed to do is decompose it. And actually, one of the, I will throw out there, that this particular lesson that we're on right now, because of the fact that you're doing this in Precalculus, which I don't remember doing in my college Precalculus class that I had to go back and take after I'd already gone through Cal 2, stupid LCU. If I can do Cal 2, why do I have to go back and do trig and Precal, stupid morons? That was dumb. Anyway, I don't remember, but anyway, the fact that you're doing this and like learning it decently well, one of the harder things in Cal 2 would be easier because you're doing this. Not easy, but easier. What?
I'm not going to take Cal 2.
Just watch. You're going to end up deciding later in life that you're going to want to do something that you have to take calculus for. All right. I don't even know why I'm rolling this over here. Okay, so we're supposed to decompose it. Let's do it. What should we do?
Do we just rewrite it with the A and the B?
Let's see what happens.
And does it
Oh,
have
no, it
to,
has to be bx.
yeah, I was
Plus
going to say,
Oh, you're right.
Okay. I think my brain was just not wanting to process how that could work.
And then we do the parentheses for the multiplied.
I'm only seeing 2 chunks. Oh, sorry.
We only wrote 2 chunks. I'm glad you're only seeing 2 chunks. Because there are in fact only 2 chunks. So, I'm going to distribute the things. Left side is still the left side. 1 equals this one will be times x squared plus 1, and this one, I don't know why I wrote a b, equals, how about a plus? That would make more sense, right? Plus c times x plus 2. Then we start distributing stuff. See, this is why after Algebra 1, math starts to get more fun to teach, because it's a little bit annoying to bang your head against the wall trying to teach kids how to graph a line. Equals ax squared plus a plus bx squared plus 2bx plus cx plus 2c. We start shoving stuff together. There's the x squared terms right there and there. So a plus b times x squared. X terms right there and right there. Plus the 2b plus c times x. And then finally the no x terms. X to the 0. Plus a plus 2c times x to the 0. See, that's the difference. In Algebra 2, I was irritating them by not closing my parentheses. And here we get to have fun by adding x to the 0. Okay. We make it a system. A plus b equals 9. 2b plus c equals 16. And a plus 2c equals 1. Not Juan, but 1.
Oh no, none of those match. So you're just gonna have to.
Oh no,
match
it's a
the-
3x3
I know,
system.
I matched 3 to 1, and then I matched what I got from that to 2. I
was
matched
trying to
3
do-
to 1 because if I just turn 3 negative or 1 negative,
I get you.
then you get rid of the A, but then you're left with B and C. But
Yeah.
then you have B and C there
Yeah.
too. So then you
Yeah, do it by elimination, sure.
I don't even see the number 3. Where's
No,
it?
just like row 3.
Oh, 3. Got it.
Not 3 the number, 3 the concept.
For the concept.
Yeah, or you could even do this if you wanted.
Yes, but I was silly and did not want to do that.
What is it you doing, Graham's rule?
Nah, I'm not doing Kramer's rule.
Can we shove that in the calculator?
Yeah.
Yay! Oh, I like how to.
Y'all go ahead and shove it in the calculator, see whether I beat you or not.
Probably gonna beat us. We're going slow on the calculator.
I mean,
Because
I
that would be funny. Yes, but you were racing.
It's not racing. I was just going
Can't
quickly.
see it.
I forgot where I gotta go.
It's on your paper. You don't have to see it.
No, I don't have any space, so I gave up right as I found it.
Hello, data matrix. Current.
Wait, what even is this?
I'm not even doing a fast method.
I can't see one.
There's the
Is
system.
it a 3x3?
Yeah.
Or is it a 3x4?
It's a 3x3, well, 3x3 matrix if you're doing this method.
3x4.
That's the system. That's what you need to. I'm talking to Garrett. Just write down the matrix yourself.
Oh, zeros, no doubt. I was trying to figure out how the heck to write it down. I figured it out.
Oh wait, I don't know how to do the
doing the?
I thought it on the calculator.
Nice. Which method did you use? The just Gaussian elimination?
I was gonna shove it in there and then do the hard.
Yeah, Gaussian elimination. You did what I did, but with the machine.
I mean, I did it on the paper with the
With elimination, nice. Good job. You learned a new method because when you came in, you only knew substitution. You have learned something. That's great. We love it.
I can't go home. Just want to go home.
I want to go home.
I mean, on the calculator.
I want to go home or physical home.
I think I need to do.
So we need to find what does z equal? Solve z. How do I solve z?
What did you get? What did you get?
180.
Okay, good. I thought I did something wrong.
I don't know what to do next. I have it in the. Where's my? Okay, just do that. I have the matrix. That's all I have.
I'm gonna say this is comedy.
You have to have reduced row echelon form, bro. I feel like you should have just rented the calculator.
Probably, honestly, that might have made my life a lot easier.
You have the 3 and
At
the
this
4.
point, elimination is probably like a million times easier.
I don't know how did you go like that?
That's what we did last time.
Well, I was wondering.
Honestly, I think what I would do, I know I like yelled at you about this, but I think if I was like tasked with this and I was told I had to do it by hand, I would actually solve this one with substitution.
Elimination, I just happened to stumble into
Elimination totally works simple too. Elimination or substitution would both be easy.
How would you solve this with substitution?
I would first do this, and then I would shove this one into this one.
Z.
That makes sense.
Just shove things in other
Well,
things.
now it's just a 4x4 or 3x4.
It should be a 3x4 with.
Row echelon.
I don't know how to put it in row echelon.
I feel like that's something you need to study for this test is how to do all the things on your calculator or borrow another one or something else.
I forgot how to do row echelon.
On your calculator?
Yeah.
It's easy on there.
No, it's easy. I can just type in RREF. Buttons.
So let's try that.
That's funny. That's funny.
The guy on the video that I watched was like, you can do all this, or you can just type it in on your
Wait, there's gotta be.
Wonder if mine would do that.
It probably could. They have added some of that logic in there.
Where's the matrix?
Wherever Neo is.
Wherever Neo is. I should source this up. 'Cause I'm interested in how to do this.
No, because on my calculator, all of the letters are
Found it.
equal to 0. So it's just
Oh.
multiplying 0 by 0 by 0 by 0 by matrix.
That's funny.
I found it, but it is not the answer that y'all got.
What did you get?
But I don't think you got
Is that right?
No.
it. The bottom.
Oh look, I was doing well because C is 0, right? Is that what y'all got?